Okay, our topic for tonight, persistent data. I had a label up here and I erased it. I didn't mean to erase the label. I meant to erase the things under the label. We want, when we write a piece of software, we don't want to re-input the data every time we run it. Because a lot of it's never going to change, right? We don't want to re-input what changes. So we need to keep things around. And the first way we would do that, our first option is what's called a sequential text file. And the key part there is sequence, the order. We keep track of the data because of the order we write it to the file. We write every data point to its own line in the file. So then when we read it back, we know the order that it's in. So we can read it back and put it in the same variables it was written. It gives us a way to that's how we organize it. So organize data by the order we write and read it in. Because we're the ones that wrote it to the file. So as long as we read it back in the same order, we know which order we wrote it in. So we can just put it back in the variables in the same order and keep track of, get it back to a previous state of this stuff. This is what the book talks about. There are better options. So that's what is in the textbook and the reading assignment for this week. The second one, a good one, a good option, a slightly better option would be a comma separated variable file, CSV. So it's kind of like an array. We delimit the data. Related data all goes to the same line. And then we delimit or separate our data with a special character. Delimit with a special character. And from the name, you can probably figure out pretty quick that special character is usually a comma. But sometimes we might have strings that include commas in them, and we're worried about that messing up. Because that would be part of our data, not the thing separating our data points. So we have control over that. We can choose any character we want to be the delimiter. Spreadsheets built up from CSV files. So we started making improvements on CSV files. They got larger and larger and larger, and spreadsheets were created from CSV files. That's a good organized way, and we haven't talked about arrays yet, but you also have arrays and lists in previous classes. So related data goes to the same line, and I'm going to write the word array here. So we put things in an array, or really a list. I'll just leave an array there. A list so that we can mix our data types, because arrays are all the same type of data. A little technicality we'll talk about soon. But you can think of it as all of our data that's related, like a particular employee in our payroll example there. We put their name, first name, last name, rate of pay, hire date, birth date, all of that stuff into one list, and then, or array, and then that becomes one row in our CSV file. So then we keep everything organized that way. Then we just need to split it back. When we get it back, we can read it right back into an array. I still on the board here? Okay, yeah. And the third one, one of our primary methods of storing structured data is a relational database. SQLite is included in Python language. So we have a relational database built into the Python programming language. A really nice one that is designed to go with programming languages. SQL, structured query language. Something that some people offer first is that's not a single language, that's a category of languages. There are thousands of them, and we can customize them. We can customize any of those thousands, make them unique to ourselves. So that's structured query language is a category. So it might be slightly different than the SQL you know, but it'll be very, very similar. I don't think our select statements ever change. Our insert statements never change. One of the things I always look at to tell which flavor of SQL I'm looking at, one of the first things I look at is how is auto increment. Because auto increment is written differently. So there are certain keywords that we can look at to narrow things down. If you haven't ever seen SQL, that part of the lecture is going to be confusing. We will see that. We'll see that. It might seem a little confusing. I'll try to cover some of it, but we are restricted for time, so that'll be kind of quick and or directed towards the people that have seen relational databases. Our best way to store structured data. Structured data means we know the same thing about all of our representatives. So we'll put things in like a table. You can think of a table. So relational, each data point gets its own field, one cell in a table, and then related fields form records or like rows in a table. So if we had like employee data, one cell for a particular employee might be their first name, another cell their last name, then their age, their birthday, and all that data we know about them. And all of that's related because it's all representing the same individual. And then our next row, we would know the same data about them, right? From the forms and paperwork they filled out when they got hired. And all of our data, we'd make a nice, great big grid. And when we can fill in that entire table, or at least, we might miss things here and there, but when we should be able to fill in every cell in that table, that's structured data. So think about a form. If everybody goes to a website and fills out the same form, their database has the exact same information about everybody. We know exactly what is in each column. Opposed to that is unstructured data, and that's like what we would grab from social media, right? Maybe we know one person drives a yellow Mustang, and somebody else ate at Applebee's last Saturday. Somebody else has a birthday party this weekend. Somebody else just bought a University of Kentucky basketball T-shirt. So maybe, right? We know different data about everybody. Somebody else has size 14 shoes. Somebody else went to high school in Jeffersonville. And we know different data points about everybody. That would look awful in a table. We would have more empty cells than full cells. That's unstructured data. So for structured data, we use relational databases, which are controlled with a language called SQL, structured query language, and we go ahead and pronounce it as SQL. We just add the vowels into the acronym. And SQL works with relational databases and non-relational databases. For unstructured data, we usually call those NoSQL. even though the language and keywords that we use to control those, people put lots and lots of effort into making it as close to SQL as they can. That way database administrators don't have to learn a new language. It seems like they're doing the same language, but we often use the word SQL and NoSQL because they're just easier to say than relational and non-relational. Those are kind of a mouthful. So those are the three I want to look at. We might look at JSON. That's just writing a file. That's probably the most popular way to transfer stuff in the world anymore. XML. There's lots of very, very common ones. I'm going to start down this list and see how many we can get through before it seems like a good amount of time to end the lecture and switch to that. And I have videos where I can go through them. So if we don't get all the way to over here, because at this point, not everybody's had a database class. How many of y'all have had DBMS 110? See your hand up in the classroom. What about on Zoom call? Any of y'all had DBMS 110? I'm guessing not then, right? Okay. Yeah, so a lot of y'all haven't seen SQL. I know you have, James. You might not have had the class, but that's what you do every day at work, right? So I do have a video if we don't get that, because I know not everybody's got to SQL. But the main thing is SQL is included in the Python programming language. So we have SQLite to work with every time. So let's go ahead and look at some more examples, see how far we get through these. I'll share my screen. And while we're talking about writing files, I want to do one quick little side step here, because there's a Python code that's written here. That's just Unicode text file, right? The only difference is we gave it the .py extension, and extensions are for the computer, they're arbitrary. We could give it whatever extension we want. It still has Python code in it. If we told the computer to run it, it would. If we told the computer to run it through the Python interpreter, it would still work right. So our code is a text file. So is something we can do. Just throwing these in here, because I would highly, highly recommend doing this if you can, because in the long run, if you're heading for software development, modern software is big and complex. So a lot of times what we write is we write a script that writes the actual program we want, because it's too complicated to write the actual program. We need a computer to keep that straight. So we write a program that writes the program we want. So for here, we could create a new file. I'll say with open run this.py. You all know what that file extension represents, right? It's a text file. It's just for holding Python code. And the py just automatically tells the computer what to run that file with, which we can override. We'll open that for write in write mode. And, oh, I forgot part of it. I'll make up here as to file, or I'll call it write script this time. And do things like write script dot write. We'll say print. Then in the escape sequence to type of quote marks. Hello world. Escape sequence for the quote marks that actually want to print to the file. Then a parenthesis, close that string. Why is that marked? Oh. Indentation. I spelled script backwards. I put IR. I think I'm used. Yeah. Just a quick typo. But that line looks familiar. Just a small one, right? If I run that, we can see there's a Python file over here that we can run. So we can write another file, and I would highly, highly recommend doing that, giving that a try. If you've seen HTML, that would be good practice as well. Define web page. And again, we'll open a file handler. So with open, look at this.html. For write mode is create page. Just give some arbitrary name to our file handler. Looking at the syntax again, we can start writing some HTML code. Create page dot write, and I'm going to skip the doc string. So I'll just start with the HTML, do a line break, then I'll do a head section with a title in it. Written by script. Close the title tag, close the head section, and maybe another line break. And that's getting kind of messy, so I'll come down and do another string. And just start writing HTML code from to a file. Oops. Create page dot write. I guess now we're up to the body tag for those who have seen HTML. In the body, we'll set a big header that says hello world, the standard, close that header, and then a paragraph. This page was created by a Python script. And that'll be good. So in the body tag and in the HTML code encoding. So I run that. Oh, wait, I have to actually run it. Web page. Remember to call the function and then run that. We have a new file up there of HTML code, or if I come over here, can open it up and we get the HTML code. That is one you will definitely do as a software developer. So if you're in the SDEV pathway, you had to take the HTML class. I think you also had to take the HTML class, right? It goes across networks. But all of you have to take that class, and you're not going to sit there and write up your web pages in text. Web pages are mostly created by artists that drag their mouse around. What you're going to do is write Python code where an artist can drag their mouse around and it creates a file like this. So those two things, I would highly, highly recommend doing that. Probably something better than a hello world. But that is a skill that will be critical if you're heading into a software development. You want to write that file. A couple of y'all are in the game development class. This is what your game engine does. Your game engine, the one we're looking at this week and next week, we're dragging a mouse around, and it writes a text file in the background that compiles it and runs. So that's usually what we do. When we get to Unity, the same thing. We drag our mouse around, follow the controls on the interface, and then that writes a text file of code, compiles that, and then runs that. Or you do it with Python and create a Python script. So you could make that might be a good project if you want to take on a challenge. You can get the first few steps. There wouldn't be time to finish it in our class. But you could make a few things on a PK interface package here for this class where you drag your mouse around and activate functions from button clicks and stuff that write a Pygame script in the background. just doing this right here. Just open up a text file and write some Python code, do it on a button click, and put an interface on that Pygame stuff we were doing last week in that afternoon class. That might make a good project for this class, but obviously that would be huge, massive. That would take 20 people a year to eventually get all the buttons that cover everything Pygame can do. But you could do the first couple steps. You could do a proof of concept of it and practice that, because that is something you will do as software developers. Your script will write more complicated code because the software is too complicated for a human to keep track of. So we keep track of the pattern that creates it, and then the computer handles all the complicated part or complex part. Definitely practice those as soon as you can. Use your program to write another program. So now we're stuck with saving data. Save these, and I will put these on the GitHub repository right after class. Do I know where the button is? If I don't see the button, yeah, I'd have to dig around and look for it. I could tie it straight to GitHub from an IDE. That's one of the tools developers need, so it's worked into our text editors. I still call this a text editor. I call it a Slider text editor, not the IDE, because all I do with it is edit text files. But back to our main point tonight, persistent data. The basic one, the one the book covers, is we put things in the same order. So maybe a sales tax. That'd be a good little quick example that we can put in different types of different things. So we'll set up an input. So choice is an input. There's another item. Yeah, I'll do it this way. Is there another item? Ask that question. Yes or no. And then we can check what while those boxes keep blocking my view. While choice, there's a lot of ways we can enter yes or no. So we saw this the other day. Let's make it all lowercase, and then we only have to check once. While choice.lower is equal to yes, we'll keep adding prices. Price is input of how much is it? Oh, which needs to be a float. So if I type the word float and then hold shift and push in so that everything's highlighted, all I need to do is hit the opening quote marks and it'll fill out the closing ones. Oh, whoops. That's not going to work what I typed there anyway. Well, choice is equal to yes in all lowercase letters. Then we'll go in here and be like, how much is it? We get that price. We need a total, which obviously starts at 0. Total. I'll do the sales tax first. I'll just use Indiana sales tax. So tax is 0.7%, right? 7 cents on the dollar in Indiana. So the tax is going to be the price times the tax rate in Indiana. And then our total will go up by price plus tax. And then we'll ask again. This. And then when we're done, we can just output something. Print the total is and this will work for the console. This is what we've been seeing so far, right? Is there another item? Yes. How much is it? Say 1234. Is there another item? Yes. It's going to be 9765. Yes, there's another one. How much is it? 1455. And that'll be it. Oh, whoops. It would probably be helpful if I actually printed out the total, but I can look up here and see what the total is. So we can see it worked. I was going to save some data, but I didn't bother to put the sales tax as a variable or anything. So let's do something different with this one. Let's keep looking at file writing examples. And then I will send out some videos after class when I did this before to cover these types of data. There's more than one reason, and I have some previous videos on the other ones. Or example files. Do I have comments in these? That's why I had the other computer out. So open that. Not really commenting that. I'll just copy from that after we do this. But this will be another place where we want something. Because if we go bring up a bunch of items at the cash register, what's missing from what we would get at a store? Oh, okay, save that. This is point of sale. Point of sale, PY. Run that. Is there another item? Oh, whoops, my cursor's in the wrong place. Yes, there is. 1234. Yes, something for $1.99. Yes, there's something else for $14.56. And that'll be it. And we get our total. Add a space and a $sign on that. Let's change that to format. Total to 2 decimal places. We've seen that so far. But what's missing from the store? Right? We get our total. I may fix the typos, so that'll be fine on the next round. And we grab our items and head out the door. We're missing something, right? What else would the store give us? Because right now, all it did was tell us the total.
The price?
Oh, well, we have the price. I was thinking of a receipt.
Yeah.
We might need to return our items, right? That $14 item's no good. We get there and it's like, oh, this was broken in the package. What are they gonna ask? Do you have a receipt? So that'd be another use for some software. So let's create a receipt. So this time, and this is where we would normally use the one with the book, because we're not going to write the file all at once. We're going to keep coming around that loop and doing different things before we finish writing that file. So this is where we would come in with the bookstore. So I'll call it receipt. I spelled that wrong. R-E-C-I-E-T. Is a new file handler. I need static numbers, but we haven't seen those yet. I'm just going to call it receipt.txt. Open that for write, and we'll just assume we're going to copy it for every new user or something. There's ways we could keep a counter for every run of the program, not just the current program, but that's going to be complicated for an example. So I'm just going to write one file, and we'll see that stuff later. So once we get this, we can print these numbers out. So receipt printer, that's a better word for it. Receipt printer dot write, and we can write string. Actually, we probably want to format stuff, don't we? Format price to 2 decimal places. Which, remember, we read this backwards. So a floating point number shows 2 places after the decimal.
So excuse me, where you write format, you can actually just write F.
That's a different one.
Okay, I'm getting.
So F goes out here. And then we do that for the whole string. There's more than one version. I would recommend this one for now. Because I'm going to show more still, different ones. So this is probably the one you want to go with. Because that's like what you were doing with the string and end and float. And that way it's minimize the stuff because there's going to be a lot of it that we see. We have to fit a whole lot of stuff in a very short period of time.
So if you want to convey both float and string, that's when you use the other F, right?
Mhm.
Okay.
If we wanted to just put the whole thing in there. So it works better if our data had that F formatted strings work better if our data is strings and integers and things where we're not going to end up with a whole bunch of decimals. It's not so good for floating point numbers. Point to F. So we'll put in the tax. I guess we need some words here, don't we? Price plus that formatted price value. Tab over, and then we'll type tax plus that formatted tax value plus tab over and well, I can leave the running total off. Can't I? We don't need to see the running total until the end. We want to see the tax on each one because in an actual sales tax is different, right? I thought today at the Dollar Tree, which one is it? Reese's are taxed because they count as a snack, but Kit Kat counts as food, so there's no tax on Kit Kat. Which is odd because peanut butter has more nutritional value than those wafers in a Kit Kat, but for some reason Kit Kat counts as food and Reese's do not. And then after we do all that, then we would close this. Receipt printer dot close. Or I'll do that at the very end. Actually, I'll retype it because I spelled it wrong. Close to finish everything up. So this is when we would spread it out that way. If we're gonna do a whole bunch of other stuff using nested inside of someplace. So now when we do this, close this. And I don't like working at the bottom of the screen. It's more room there. Run this. Is there another item? Yes, there is. 1234. Another one. Let's say 1843. Whatever I just typed there. Another one at $1.99. Yes, another one of those $1.99 things. Yes, maybe there's something for 21.21. And that'll be it for today. And then we get our total. Get rid of that extra one. So we have our total. We pay the price and everything. But over in our files, there's now a receipt of what all those items cost. We can see that. Looks like I forgot the line breaks, right? That wouldn't fit very nicely at all on receipt paper. So we probably want a line feed at the end so that it goes to the next line. Let's see. Yes, there's another one. For that much, yes, there's something for 47.54. Yes, for something for $9.99. And that's it for today. We get our total. And over in that receipt file, we have that printout of the actual receipt. I guess we need the total printed on there somewhere too, right? So when we get all the way down here, print a couple line breaks to spread it out, and then I'll copy all this stuff. Oh, why didn't I like that? EOL while scanning literal. Oh, extra quote mark. Yeah. Oh, I typed the wrong thing in there, but it clearly wasn't a guess. Let me try that again. Clear that, and then rerun that. Is there another item? Yes, there is. Cost that much? Yes, there's something for $98.76, and yes, something for $1.08, and yes, something for $14.56, and that'll be it. So we get our total, and oh, I did not mean to print that twice. But notice how we keep having to enter those same test cases over and over again. It'd be nice if we could just read the test case off a file and avoid all that retyping stuff in while we get those little bugs worked out, right? $4.32. Yes, there's something for $98.76. Yes, something for $1.99. Yes, something else for $1.99. So we get all that, and if we look at the receipt, then we have that printout of the receipt, a more useful format. Same thing for that one we're building up. We've always been putting it in the console. It'd probably be a whole lot better if we had that data in a file instead of the console. What's on next week's agenda? Let me double check something real quick. I might come back and do those things that I put on the board earlier next week, and then actually storing data for our file, which means the homework will be okay to turn in late if we haven't talked about it in class. So if we don't talk about it in class till Monday, you can have a couple extra days in case it's going to show up in the homework. But the basic idea is we put it in order. What is on tech for next week? I think it's list and arrays. And I didn't want to go all the way to 8:50 tonight. That way y'all have plenty of time to start clicking around and doing things. This one. And next Monday will be okay, yes. These three things specifically, like storing the data so that we can bring it back in and put it in the same variables and continue from the spot our program stopped. I'm pushing that back to Monday and just looking at the basic file rating tonight. So like writing a receipt, and a similar thing would happen with that payroll thing we've been working on, right? Which I think is in here. If I open that up. And give that a new name. I always work on a copy. So no major changes. The only thing we're changing is the output. So maybe instead of 2, that's the next version. So it's not up to version. It's not up to version 3 yet. It's still version 2, but the output's changed. That's a big change. That's new. That's the new middle number, the release. It's not just a patch. So we get all our data, calculate this stuff, but to the console is not much use for us. So instead of printing it to the console, I'd like to print it to a file. So I'll do that here. So I'll create a new file handler. I'll call it pay stub printer is open weeklypay.txt, and the extension is arbitrary. We can call that whatever we want. When we get to these things, we'll start making up something. That way it doesn't look like a text file. It'll be something related to our program. Like we could give it the extension, make it a .SDEV 140 file. And the computer won't have a clue what to do with that, but we'll know what that opens with our stuff. So open that up to write a file. And then instead of print, I want to do paste printer dot write all of this, but write itself doesn't have a line command. So I'll grab this and paste it in here. And then another line break at the end. And then hopefully now I don't think we'll need this. And we get by without those lines. And on these, I'll print that in there. And then these two empty print statements were just to get just to get some space between stuff. So instead of doing that, I'll add 3 line breaks on this one to spread things out. So I took those print statements we already had, and now instead of going to the console, it's going to a file, which would be a lot more useful, right? Hit run. So who is it? I'll make up some name. Sally worked 33 hours and makes $21.21 per hour. Yes, there's somebody else. These do not represent people. I'm just making up these names, trying to use some common names that do not represent anybody in particular. Maybe Bob worked 45 hours and makes $23.45 an hour. Yes, somebody else. Who is it? Becky, again, just making up a name. Maybe Becky makes $19 per hour. She's new, hasn't got to her first raise yet. Be a big first raise to bump up into 21 per hour range or something. Probationary period or something. Oh, well, that was hours. She worked 19 hours, so she's just starting out. And we're then back to she makes $19 an hour. Then nope, that's it. So the program comes to an end, we don't see any output, but we should have a file. There it is. Uh-oh, nothing in the text file. This is that standard precaution I mentioned earlier. We did not receive any error messages. Everything ran like it should. Our print statements should have gone to that file, but they didn't. Does anybody see what I left off? Can I get all of the, okay, yeah. So all of the code that was changed is on the screen right now. So the created a file handler called paystub printer. Then we started printing some lines, writing some lines. If there was something wrong with writing the line, we would have got an error message, right? No error message, but nothing showed up in the file. Does anybody notice something
That
missing?
is exactly what happened in my last, what?
So this is a standard way actually worked into programming languages to help us notice something. I kept doing it on purpose tonight. Let me write some code. Whoops. I have no idea where my cursor was. I just typed a couple letters, but I have no idea where. Right? I can notice that. Where did, oh, yeah. My cursor was apparently right there. That's not where I meant to write code. I'm intelligent. I'm an intelligent creature. I will notice that the cursor is in the wrong spot. That's not the case with a computer. If the computer is looking at the wrong spot, it will just continue to carry out instructions. So as a precaution against that, we do not actually, the data does not actually show up in the file until we close our handler. It's like our handler is greedy with the file. Nothing else can get to the data that it's trying to put there. And if we forget, and nothing else can get to that data until we close the handler and shut it down. It's holding the data, so nothing else can reach it. So it doesn't actually show up in the text file until we close. Paste of printer dot close. You will see that in most of your programming languages. It's just a little precaution. If there's no error messages and nothing showed up in the file, because you forgot to close it. So you'll see that quite a bit. So now if we run this and enter some names, Sally makes 23.45 an hour. Work 23.45 hours and makes $19. Just say everybody makes $19. Yes. Bob worked 43 hours and also makes $19 an hour. Yes. Becky worked 32 hours and makes $19 an hour. And that'll be it for today. We only got the 3 people. No error messages. This showed up. This one doesn't have much on it. If I come over here before we even look at it in the File Explorer, we have some data there, right? It says it's 1 kilobyte. Probably should have looked at it last time. Last time it would have said it was 0 kilobytes. So it looks like there's some data there. This time we got our pay stuff printed out. That number should probably be formatted, so we can come back through and do those formatted strings, since we are always talking about money here. This is a formatted string. So instead of a formatted string, I'm going to concatenate it. Employee name is a string, so we can add that to the tab. Gross pay is a number, so we need to format that. Format gross pay to 0.2F. And then we'll add a couple tabs. And then a pipe symbol. And tax deduction, that's a number, so we'll format that. Format tax deduction. So that the formatted strings, those are best for integers and strings and things that we do not have to worry about how many decimal places it's going to show. If we're worried about how many decimal places it's going to show, it's better to use a regular string and format it manually. Format net pay to 0.2F plus all those line breaks at the end. Because otherwise our stuff might not line up very well at all, right? And it's money, so we know that it's always going to be that. And since we're only talking about money, I'm just going to leave the dollar sign off because we know every number there is money. So dollar sign is just like cluttering up that. Let's make up some more names this time. So a different company, there's a David who worked 38 hours and makes 21 an hour. Yes. Maybe a Heather, again, just making up names. Heather worked 46.5 hours and she makes 24.57. Yes. One more name.
Bob.
Bob. Bob's got a couple jobs. Bob worked 39 hours and Bob makes 22 an hour. Nope, that's it. So it finishes up. And when we look at it, everything looks formatted nicely. Could probably use another tab there at the beginning, but that's just formatting stuff. But see how much better that looks in a text file than the console? Names might be long, so maybe we should leave lots of space for a name. I'm not going to run it again. But we don't know how long people's names are, so I'm going to add 2 more tabs, which will be 10 more characters. So now we can go 15 characters on a name. And then things will line up.
So each of the tab takes
Oh, wait, sorry. Each of the tabs takes up 4. In Python, we can do tab, one big tab, or several spaces. And in Python, the Python, people that create the Python language, we can use either one. We can use a tab or multiple spaces. And we just can't use them together. We can't put 4 spaces on line 39 and then a tab on line 42. We have to pick one or the other, but we do get our choice of one or the other, and we can't mix them in the same file. The people at Python say use 4 spaces. So a Python text editor like this will probably be set up so the tab is 4 spaces. So that gives us 12 characters per name. Maybe one more. 16 characters for a name is probably more than enough, right? Let's run that, do a couple names. Sally, who worked 43 hours and makes 21 an hour. Yes. Then Bob, who worked 38 hours and makes 23.45 an hour. Yes. Then we have Becky, who worked 29 hours and makes $19 an hour. Nope, that's it. So a couple things on this last little example. Okay, looks like it lined up. Oh, that last one might be too far over. One too many tabs on the label. Now that everything's formatted, we don't need to add extra spaces for the next. Those are always going to be the same. But this data, that's always going to be the same, right? Most people, Bob and Sally and Becky, aren't going to change their name. Most people get a raise once a year, maybe twice a year. Some jobs like to do it twice, give 2 small raises per year instead of 1 big raise per year, because then you don't have to wait as long till your paycheck goes up. And people like that. But we're having to re-enter that every time, and that's where this comes in. So instead of the output like we did on the receipt or the pay stub here, it'd be nice to have that name, rate of pay. It'd be nice to not have to type that in every single week at the same company, right? It'd be nice if we could save that. So that's the next thing we're going to look at. And I'm going to push that back till next week. So your programming assignment homework, you'll have a couple extra days because we won't have talked about all the files. And homework is not, if we haven't talked about it in the lecture, the homework over, it's not going to be due yet. But that's what these things are. The data are consistent. The data our software works with, we keep that around and reuse it. the only thing that we really should have to enter is the hours. And we should only have to enter how many hours people work each week. We know their name and the rate of pay. So we'll look at these three things on Monday and then get into a raise and list because y'all have seen a raise and list before. The lecture part on that will go quickly. And that leaves us 46 minutes. So 45 minutes left to apply some of these things. And my very first recommendation is that one that I pointed out earlier. Did I close the file? I already closed the file, didn't I? File stuff. I'm getting ready to put these on the GitHub page. But on this one, I think. Nope. The one that did that. That's my recommendation. Oh, I guess it's this one. If you know how to write a text file and you know that programming is just a text file, write a program that writes another program. That is an important thing to practice. So that's my first recommendation for the next 45 minutes. But it's your time to work on whatever you feel the need to work on. I know some of y'all have had a long day because you've been in class since 1 o'clock. I know because I was there too. But that'll be it for this evening, and we'll look at that next step on Monday because the lecture for next week's content will be short on Monday. Does anybody have any questions about that before we wrap up here? Oh, there's a message. Was that a DM? Also, I guess that's kind of like a question. Oh, that was from earlier. That made me think of direct messages. If you want to DM me during class, my laptop is supposed to say Chris, and then in parentheses it'll say what machine it is. So it'll say like Chris CD if I'm on the Chromebook, or Chris Mac if I'm on the Mac. So it'll say Chris and then parentheses, and that's the machine I'm standing beside if you want to send me DMs during class. Oh yeah, any questions? Okay, if you have any questions, let me know. I am always happy to help. Otherwise, you all have a great weekend. I think we have another day or so of nice weather left, so please enjoy that. Try to find time to get to a park and enjoy the nice weather before winter comes in. We don't have many nice days left this season. So otherwise, I'll see y'all on Monday. You have a great weekend.
You too. You have a great weekend.
It's odd to say have a good weekend on Wednesday. Have a good rest of your week and then the weekend.
Yeah, same here. I made a mistake too.
See ya.